Hello everyone. In today's video, I will explain the step-by-step procedure of how to determine the relationship between modulus of elasticity and modulus of rigidity. Here, we know that the modulus of elasticity, which is denoted by the term capital E, is defined as the ratio of stress to the strain. Here, the stress is denoted by the term sigma and strain is denoted by the term small e. Now, the modulus of rigidity, which is denoted by the term G, capital G. So, it is defined as the ratio of shear stress to the shear strain. And shear stress is denoted by the term tau and shear strain is denoted by the term pi. Now, here we have considered a square element ABCD of size L and which is subjected to a pure shear stresses. This is denoted by the term tau. And due to this stresses, what happened? The block will be subjected to deformation. Now here, let's assume that this base is fixed and the shear stress is acting in the block. So the deformation of the block can be either this side or that side. So let's assume that the deformation of the block is towards the left side, this side, due to the shear stresses. Then what will happen here? Here this diagonal BD, this BD line will get elongated and the diagonal AC will get compressed as shown in this figure. So this A, D1, C1 and B is the deformed shape due to the shear stress. Now here we draw a perpendicular line D2 to diagonal B, D1. Now let's this one pi be the shear strain and G is the modulus of rigidity. Here this diagonal BD will be elongated and a new line or new length, this length that is BD1 and the diagonal AC, this AC will be compressed and a new diagonal that is AC1. Now firstly, we have to determine the linear strain of this BD. Now, what is linear strain? Linear strain is defined as change in length to the original length. So here, linear strain of BD, we can write delta L by L. Here, the original length was BD is L and after elongation, the length will become BD1. So, in place of delta L, we can write BD1 minus BD. This is the change in length, BD1. This is the BD1 minus BD. This is the change in length. And the original length was B to D. Here, as we have drawn this perpendicular D2 with diagonal B, D1. And here, what we can see is the deformation is very small. So, we can write this BD is equal to BD2. So, BD2. So, in place of BD, we can write BD2. So, now the equation became BD1 minus BD2. That is BD1 minus BD2 till here. So, it will be D1, D2. So, D1, D2 by BD. Let's consider it as equation 1. So, now next we'll find the value of BD in equation 1. So, here this A, B, C, and D is a square element. So, this angle A is 90 degree. So, according to the Pythagoras theorem, we can write that this BD square is equal to AD square plus AB square. So here, as it is a square element, so this AD is equal to AB. Now, in this equation, in this Pythagoras equation, we can write in place of AB, we can write AD. So it will become AD square. So the equations will become BD is equal to root under 2AD. Now, next is to find the value of D1, D2 in equation 1. Here, this angle of deformation is very small. Here I have separately drawn this angle of deformation, which is very small. So we can assume that this angle is 45 degree. So we know that cos theta is equal to adjacent side by the hypotenuse. So here the adjacent side is D1, D2 and the hypotenuse is D1. So the cos 45 is equal to D1 D2 divided by the D1. So the equations became D1 D2 is equal to D1 cos 45 degree. Now put this value in equation 1. Now we know the value of cos 45 here. The cos 45 degree is equal to 1 by root under 2. Here this is the equation 1. This is the equation 1 and we need to put the value of D1, D2 and BD in equation 1. Here the value of D1, D2 is D1 cos 45 and the value of BD is root under 2 AD. So we know the value of cos 45 here, that is 1 by root under 2. So the linear strain of BD that we get is D1 by 2 AD. Now next is to find the value of this one, linear strain of BD, that is D1 by 2 AD. Now, now here we'll consider this triangle ADD1. So here the angle of deformation is very small. So the value of this pi will also be very small. So tan theta is equal to opposite side divided by the adjacent side. Opposite side is D1 and the adjacent side is AD. So here, as the deformation is very small, we can say that tan theta is equal to tan pi is equal to pi. Therefore, pi is equal to D1 by AD. Now, put this value in this equation, that is linear strain of BD. So here what we got is the value of pi is D1 by AD. So D1 by AD, we can write it as pi. So now we'll get the linear strain of BD is pi by 2. Now we know that the rigidity of modulus G is equal to shear stress by shear strain. So we can write that this pi is equal to tau by G. Now this value in the linear equation of BD and the equations became tau by 2G and considered it as equation 2. Now as we know that this shear stresses which is acting in the body causes tensile stress to the BD and compressive stress on AC. So first we will find the tensile strength on BD due to the tensile stress on BD. So here we know that the modulus of elasticity, that is E is equal to tau by E. Tau is the shear stress. Here the stress is in the form of shear stress. So we can write that the strain is equal to tau by E. Okay, so now next is to find the tensile strength on BD due to the compressive stress on AD. So here we know that this Poisson's ratio, that is mu, or it can be denoted 1 by m, is equal to lateral strain to the linear strain. Here if we move this one lateral strain here, so the equation became 1 by m into linear strain, and linear strain is nothing but tau by E. So here the tensile strength on BD due to the compressive strength on AC becomes 1 by m into tau by E. Now the total strain on BD is equal to, we have to add this both. So that is 1 by m into tau by E plus tau by E. So the equations becomes tau by E bracket 1 plus 1 by m, and consider it as equation 3. So the total strain on BD is equal to tau by E 1 plus 1 by m. Now by equating equation 2 and 3, we get E is equal to 2g 1 plus 1 by m. So this is the relations between E, G and the Poisson's ratio. Here Poisson's ratio is the 1 by m, and G is the modulus of rigidity, and E is the modulus of elasticity. Thank you.